Hello and welcome to the aligned DBpedia use case phase 2 trial platform demonstrator video. In this video we will present DBpedia and how DBpedia is being improved through the technology developed for the aligned project phase 2 trials. DBpedia is a crowdsourced community effort to extract structured information from Wikipedia and make this information available on the web of data as a large-scale multilingual semantic knowledge graph. DBpedia allows people to ask sophisticated queries against Wikipedia, to link different data sets on the web to Wikipedia data, as well as enable new mechanisms for navigating, linking, and improving the encyclopedia itself. DBpedia describes millions of things with facts such as textual descriptions, depictions, and geocoordinates. All of these facts are classified in a consistent formal ontology that makes it easier for computers to use or make inferences about a fact. Overall, the latest DBpedia release consists of 8.8 billion facts extracted from 125 Wikipedia language editions, Wikimedia Commons, and Wikidata, 25 million links to images, 80 million links to Wikipedia categories, and 50 million links to other datasets.
Aligned tools and ontologies are thoroughly used at all stages of the DBpedia extraction and data dissemination process, including data generation, quality assessment, violation isolation, and data dissemination. Align decreases the time needed to identify and report errors in DBpedia, enabling faster development life cycles. In the first half of the Align project, we managed to validate DBpedia instance data using RDFUnit, validate links from DBpedia to other datasets with a model mapping tool, validate DBpedia infobox ontology mappings and catch instance data errors from the mapping process, and finally improve the data dissemination using data ID. RDFUnit is a flexible and scalable RDF unit testing framework that implements test-driven quality assessment methodology and can test small in-memory RDF datasets as well as parallel endpoints that contain millions or billions of facts like DBpedia. We use RDFUnit to evaluate instance data from DBpedia. RDFUnit takes the DBpedia ontology as input and automatically generates almost 10,000 test cases that run against the local triple with DBpedia data. Once the validation is complete, a report is generated for the DBpedia release manager that provides provenance and statistics, as well as violations with error counts per failed test case. The DBpedia release manager can perform basic table manipulation with the report to get a quick quality insight. The most abundant source of information in DBpedia comes from the Wikipedia infoboxes, and DBpedia set up a crowdsourced application where the DBpedia community can collaboratively map Wikipedia infoboxes to the DBpedia ontology. For example, we map infobox book to DBpedia class book, the infobox wording name to FOF name, and so on. And when we apply the mappings to a page, for example Clockwork Orange, we get back a set of triples based on the mappings we defined. There are cases, however, where the mappings are wrong and always produce wrong instance data. By converting the mappings to RDF, and in particular RML, and extending RDFUnit, we are able to catch such errors directly in the mapping definition phase and before we run the DBpedia extraction framework. The mapping validation runs on a daily cron job and reports all the problematic info boxes. A mapping editor can select his language, for example English, a template he's interested in, for example county, and see any errors. Here, for example, someone mistaken county with country and defined the predicate twin country in an administrative region, while twin country connects two countries. Thus, this mapping could result in wrong instance data whenever the mapping was applied. Our validation process catches such errors and reports them back to the editors.
The purpose of the tool is to validate sets of interlinks between a source dataset and multiple target datasets. As datasets evolve and change over time, these changes can end up invalidating already existing interlinks. So it is important to be able to find which of these interlinks are still valid and correct, and which ones are invalid and incorrect. The tool validates interlinks through standard SPARQL queries that compare the source and target resources in the interlinks to their respective datasets. So for a quick overview of the tool, it takes in 2 inputs and produces 4 outputs. The interlink validation tool fits into the DBpedia use case by providing validation of the interlinks that are to be published as part of a dataset release. A prototype of the interlink validator tool has already been used for the DBpedia version 2015-10 release, where it validated over 1.6 million interlinks and identified about 3% of them as invalid. As part of the Align Phase 2 trials, the interlink validator tool will be deployed in the DBpedia production tool chain, and its impact on DBpedia productivity, data quality, and agility will be quantified.
Data ID is a multi-layered metadata system Its core ontology provides detailed descriptions of datasets and their different manifestations, as well as relations to agents like persons or organizations in regard to their rights and responsibilities. Multiple extensions to this ontology are used to provide more details on different aspects of dataset metadata, for example, when dealing with linked data, datasets, etc. DBpedia makes use of DataID to provide exact machine-readable metadata about all DBpedia datasets, accessible alongside the data itself. It provides a reliable record about datasets, its location, licenses, provenance, and so forth. Its possible use is exemplified by the new automatically created download page for DBpedia datasets. All of the tables shown here are automatically created using a JavaScript implementation based solely on data IDs created for every language edition of DBpedia. Additionally, we use the containerization platform Docker in connection with DataID to publish DBpedia releases in Docker containers. After choosing the language edition of interest, the user only has to wait until all data is downloaded and imported into a triple store.
We hope you have enjoyed this presentation of DBpedia and how the tools of the Aligned Phase 2 trial platform are making it better. You have seen how RDFUnit reduces the effort in DBpedia data validation and increases our confidence in DBpedia data quality. How the Summer Model Mapper tool can automatically validate links between DBpedia and external datasets, identifying errors and improving DBpedia data quality. And how DataID, part of the Aligned Meta Model for software and data engineering, and its associated tools increase productivity and agility by publishing new DBpedia dataset releases.